Hey guys, it's Mr. Sheeline. This is going to be the notes for the Unit 5.2 section of Unit 5. This is going to be covering arguably one of the most important sections of Unit 5 and pretty much just the most important section for the rest of the semester, arguably. So this is covering dimensional analysis, which is also called factor label method, and we're also going to tie this into some metric conversions. So, okay, dimensional analysis, what is it? It's something that sounds kind of spooky, but realistically speaking, it's actually something that's decently simple. At least in concept, it's decently simple just because it is more or less just a way for us to convert one set of units to another, okay, as it says up here. So that's really all it is. And to do that, we use what are called conversion factors in order to change one set of units to another set of units. So here we have a whole bunch of steps which you can read out on your own. So I'm going to basically just be skipping straight to the examples where I'm going to be kind of showing you how it is that we can use these steps in order to answer these questions. Because I'm sure that there are some things in here that we're a bit fuzzy on. So, okay, so again, we're assuming that you've already read this, and if you haven't, go ahead, go through, read these instructions, and not just read them really try to understand them as well. So if you need to read them a couple of times, do it, please. Because again, this is super duper important. Okay, so take that time, go for it, read these. I'm going to go ahead and move on to the examples. So if you need to pause the video, read through them, all that good stuff. Okay. So, all right. So example 1 here in this question, they're asking us to convert 3 hours to seconds. Now, if you haven't noticed already, on this, on the background, I should say on the 3rd page of these notes, you should have all of these equivalencies. So all of these, what we can call all of these are your conversion factors. Okay, we can basically say these are all our conversion factors in here. Okay. And actually, I'll take a minute to talk about that. So remember, in 5.1 notes in the video, I talked about how I'm going to be using this word a lot, and that you need to know what that is desperately. Here's where, this is where the tire or the rubber meets the road here. So these conversion factors are what we use in order to convert one set of units to another. Okay. So here for time, which is what we're going to be using in the first example, 1 minute is equal to 60 seconds. Okay. 1 hour is equal to 60 minutes. These are, again, the conversion factors. They're just the equivalencies of 2 units in just different quantities. We already know that in 1 hour there are 60 minutes. We already know that in 1 minute that there are 60 seconds. Okay, but we're going to be using this as a ratio as a fraction more or less, in order to convert one set of units to another. So what does that look like? Okay. Well, it looks like this. So we're asked here to convert 3 hours into seconds. So just going through these steps on here, step number 1, we're starting with our measured or given numbers. So what they give us here is 3 hours. So we're going to be writing that down immediately. So I'm going to write 3 hours, and I'm going to put it in a fraction with a 1 below it. Okay. And what we do in dimensional analysis is that we're multiplying all these together. Now, it's both obviously multiplying and dividing, but we're multiplying all of these, what will be like tables or what will be fractions, ratios. We're going to be multiplying those together. So it's going to be 3 over 1 times, and then our second table here, like it's talked about in step number 2, we're going to write our old units, which are hours, because we want to convert hours to seconds. We're going to write hours on the bottom. And in this case, we're not going to jump straight to seconds because there isn't just one direct straight jump. There is minutes. Now, obviously, we can figure out how many seconds are in an hour, but just to keep things somewhat simple, I guess, just because it's not directly given to you on your conversion factor sheet, we're going to go from hours to minutes, minutes to seconds. So I'm going to write minutes up here because those are going to be our new units. And then I'm going to then go to step number 3. or I guess I already did step number 3, I meant number 4. So now what we're going to do, like what step number 4 says, we are going to put in the numbers in front of the unit labels that make the conversion equal. So we're, again, converting hours to minutes here. So what I'm going to do is check out my conversion factor sheet here, and I'm going to see that in 1 hour there are 60 minutes. So what I'm going to do is I'm going to write that in. So in 1 hour there are 60 minutes. Okay. And then the idea here is that if you were to solve for this, you would then have the equivalency of minutes of how many minutes are in 3 hours. Okay, but we're not exactly done here. Okay, because now, we cancel out these hours and we're left with minutes. So now we have to convert minutes into seconds. So we're just going to repeat step 1. We're going to write our old units on the bottom, which is now minutes, and then our new units on top. So there is step number 1, 2, and 3. And now we have to do step number 4 again, which step number 4 is now how many seconds do we have in a minute? Well, we've got 60 seconds in 1 minute. Okay. Cross out those guys. And what we'll be left with here is we'll be left with seconds. So if you're wondering, Mr. Sheeline, why is it that these guys cross out? Well, remember, even units, if you're dividing, units, because what you're doing here is that you're multiplying across the top and across the bottom, and then you're dividing, is pretty much what you're doing. So if you've got hours, if you've got one set of hours in your numerator and in your denominator, they'll cancel out. If you have minutes in the numerator and in the denominator, they'll cancel out. If you're just left with seconds in the numerator, those are the units you're left with. Okay. So again, it's more or less just multiplying across the top and then the bottom and then dividing top from the bottom. Okay, that's more or less what you're doing here. So anyway, so what we're going to do then is do exactly what I said. 3 times 60 times 60. And then this is great because it's so simple. 1 times 1 times 1. So it would look like this, realistically speaking. Okay, that's really what you're doing here. And then altogether what you would show is that it would then be 3 times more or less 3,600, which I have to pop my calculator out. And what you're left with is 10,000 and then 800 seconds. Now, because there's nowhere in here that's nowhere in here, goodness gracious me. Let's see. No, we should do this. So in order to maintain what we've been doing, I'm going to say that we've got to keep sig figs here. So because we should keep sig figs, this answer should be in the correct number of sig figs that we've been working with, which is just 1. So actually, the answer isn't 10,800, but the answer is just simply just 10,000 seconds. Okay, because again, need to go by this guy. There's a 0 next to it, so it's just 10,000. Okay, so that would be the answer to the first problem. Okay, now let's take a look at the second problem. Now this is where, more or less, this is where all of those little caveats, all of those little things talking about, metric system, we're going to be showing you what's happening there. So here, before I get into that problem, let's just take a look here. We do provide this big old table, this metric conversion chart. This is where you're going to go to in order to see where it is that what units we're converting to and from. So this has everything in here except for our basic unit, which in this case would be well, I mean, it would depend. So we just don't have our base units listed here. But remember, it's basically, and we don't have a couple others, but, and realistically speaking, what should be, there's also deca and hecto. Typically, we really don't use deca and hecto. We just go straight to kilo. So, but think of it this way. You see that separation, that line I just put in? You have a separation between your decimals. and your basically your giant huge numbers. So small numbers, super big numbers. Oh, I did actually include them down here after the fact. So we use this to navigate and to know where all of these units line up at in the metric system, all these prefixes where they line up. Because remember, these prefixes indicate a certain range of decimal places, a range of values that are within the tens place. That's the point of the metric system. So you can thank Napoleon for not so much coming up with it, but spreading it across the world. So anyway, so this is what you go to in order to know, where to go, what to do. So let's just take a look at number 2 here. So number 2, we're converting 0.3 or 0.035 milligrams into centigrams. So going through the steps again, we are going to start with our given number. We're going to immediately write that down. So it's going to be 0.035 milligrams, okay, over 1. Then we're going to go with step 2. So we're making our second table, our conversion factor here. Now, the only thing about this one is that this one's going to be a little different. So bear with me here. So we're going to follow through with step 2. We're going to write the second table, and we're going to put our old units on the bottom. Then we're going to move to number 3 here. Number 3, we're going to actually go through this caveat, and that caveat is 3 sub a. And that 3 sub a says, if you're starting with metric label, or if your starting metric label has a prefix, then you must convert to the root or to the basic unit, okay, label first before converting to a new prefix label, okay? So it means that we are going to convert from milligrams to grams, okay? We're going to convert milligrams to grams. So for number 3 here, we're going to put grams up top, milligrams below, okay? And then we're going to go here with number 4. So put the numbers in front, but we have to go with the caveat. So the caveat says here in 4a, if you're converting from metric to metric, remember the following. We're going to put a 1 in front of the unit label that contains a prefix. Okay, so that means out of these two, the mg has the prefix because it's milligram. So we're going to put a 1 there. And then it says here, look up the prefix on the metric chart and find the factor of 10 that matches it, times 10 to the whatever power, and put that number in front of the unit label with no prefix. Okay. Now it does talk about in the notes here, it does say, the scientific notation here. What you could also do is this. You go to your metric conversion, your conversion factor table. You are going to find milligram, because we're converting milligrams to grams, or just milli, I should say. And you're going to go across here, and you're going to look at this right here. They have all of these in meters. All those M's mean meters on the side. So here I'll put this M equals meters here, just so you're not confused. They're just using this basic unit in order to just kind of hold it down to know that that's what they're measuring in. So what they show here is that 1 millimeter is equal to 0.001 meters. So remember, that's the same for grams, that's the same for liters, that's the same across the board there. You could say 1 milliliter is equal to 0.001 liter. 1 milligram is equal to 0.001 grams. Okay, it's the same thing. So what we're going to do is we've already plotted this in, we're going to plot in that number for our conversion factor. So we're going to come back to here, and we're going to put in 0.001 grams. Okay. And then as of right now, if we were to solve this, we would have the answer in grams. But we're not done yet. So now we've got to go from grams to centigrams. Okay. So again, These cancel out because that's step number 5. The labels cancel out, they cross-reduce. Okay, now we're left with grams, and we have to convert grams into centigrams. So these are now our old units. They go on the bottom because they need to cancel out. And we put our new units up top, centigrams. And then we rinse and repeat. So here again, we need to put numbers in front here. Now this step is where I can't tell you the number of students, just for whatever reason, just their brains turn off and they just completely forget what they just did. So remember, back here, we put a 1 next to the milligrams, not because it's on the bottom, but because the milligrams has a prefix. So over here, we are going to put a 1 with the guy that has the prefix, which is not grams on the bottom, but centigrams on top. And I know that seems seems silly on how much I'm emphasizing this, but I cannot tell you the frustration I had with students that would come up and ask why things were wrong, and they had nothing but 1s on the bottom when they should have, they weren't putting 1s in the correct places when they were making new conversion factors, because they thought that all of them just had to go on the bottom. No. Follow the directions, follow the steps, okay? The 1 will go with the one that has the prefix. So 1 goes with centigrams, and then down here, we've got to look that up. We're going to see here, centi, go across. 1 centigram is equal to 0.01 grams. So we're going to put that 0.01 with grams here. Okay, cross out those grams, and now we should be just left with centigrams. So then it's going to be, we're multiplying across the top, then across the bottom, so 0.035 times, and I'm not going to have enough room, times 1, and then 1 times 0.01. Got to shove it in over here. And what we should have here is that we're going to have let's see. We're going to have 0.0035 centigrams as our answer. Okay. Oops, sorry. 0.0035 is our correct answer. Now, after going through this metric problem, I'm sure there are some of you that are probably kind of frustrated for this reason specifically. You're probably thinking, Mr. Sheline, we have worked with metric prefixes before, we've worked with metric conversions. Why can't I just do some bunny hops in the ladder method in order to solve for this? And this is what I'll tell you. That's fine if you can look at that and that you can look at this right here and you already know how to change milligrams to centigrams. Perfect. I'm glad you can do that. And that is definitely a method that you can use here in order to check your work. But this system is much more important than just being just knowing how to convert metric units from one to another. It's more about this system, this strategy of converting. Okay, it's just practice. And here you have an extra tool, extra strategy to double check your work. Okay. So that is that right there is the metric example from the notes. So let's just kind of continue down. I'm going to go a little quicker, and I'm not going to be explaining as much just because now we should have kind of an idea what's happening here. So for number 3, we got 5.5 kilograms that we need to convert to pounds. So I'm going to write down here 5.5 kilograms over 1. My new table, I've got pounds on the, not pounds that goes on the top. Kilograms go on the bottom. Here I'm going to go to my conversion factor sheet and I'm going to look for here, that's mass. I can see here that in 1 kilogram there are 2.24 or 2.2046 pounds, I'm going to keep it to that one. So let's see, in 1 kilogram, and I'm only putting 1 down here because that's what my conversion factor has on my conversion factor sheet. 1 kilogram is equal to 2.2046 pounds. And there, looks like that would all cancel out and I would have my new units. So 5.5 times 2.2046. And my answer that I would get out of my calculator is 12.1253. But I'm not done here. I need to convert, or not convert, but I need to shorten this down to just 2 sig figs. So then my 2 sig figs would just be 12, and then it'd be 12 pounds. Okay. Number 4, 2.5 yards to inches. So 2.5 yards, 1 on the bottom. Got yards on the bottom, inches up top. Let's see what my conversion sheet has. That's length. So let's see. I've got yards to feet, yards to meters. Looks like what I have to do here is I've got to do 2 more steps. So I got to go yards to feet. So in 1 yard, there's 3 feet. And then in 1 foot, there are 12 inches. So then it's 2.5 times 3 times 12 divided by 1 times 1 times 1. And so my answer is going to be 2.5 times 3 times 12, which is going to be 90. And we're not done here, so it comes out to a pretty even number, but unfortunately this is in one sig fig, and this is how you fix that. You put the little decimal. Great example here. Put a decimal to show that these are 2 sig figs, because that's what we have to keep it to, because that's what we start with is 2 sig figs. So 90 decimal, and I know that looks silly, but that's saying now there's 2 sig figs, and then inches. And I have my answer. Okay, 1.3 years to hours. So 1.3 years over 1. And I'm going to put years on the bottom. And let's see if my conversion factor, that's going to be time. Well, shoot, that kind of stinks. So this is one that we have to kind of come up on our own. So how many days are in a year? Well, there's 365 days in 1 year. Okay. And then now it's days to, so now our units would be days because, years then cancel out. So then we need to convert days to hours. So days go on the bottom, hours go up top. Well, in 1 day there are 24 hours. That cancels out. So now I'm left with hours. So now it's 1.3 times 365 times 24 over 1 times 1 times 1. And then plotting that all in, 1.3 times 365 times 24. That means that there are 11,388 hours. But again, because we have to keep sig figs here, our actual answer is not going to be that. It is going to be 11,000 hours or in 1 year. Okay, and we'd have our answer. Okay. Okay. So again, if you need to take a break, go ahead, pause the video, take a break, because this is a decently long video so far, and we still have a little bit to go here. Okay. So on the back side, there's just more information about metric prefixes and all that good stuff. So there are the answers for there. Let's just do a couple more here with these metric examples. So here's some info about those metric labels. So metric labels have 2 parts. There's the prefix and then the root. So the prefix shows the size of the unit. So that's these guys. So looking at your metric conversion, it's these. These are your metric prefixes. They're the ones that dictate the range that your answer is in, that your units are in. And then the root. So this is, what you're measuring. Are you measuring length with meters? Are you measuring mass with grams? Are you measuring volume with liters? What are you measuring? Are you measuring time with seconds or hours? Okay. So if both units, given and needed answer, unknown, have the same root, you can do metric conversion. So it's just saying that if you have, so you cannot convert grams to liters. Okay, they're not the same units. They don't measure the same thing. Now, there are different measurements that use both grams and liters at the same time, but that's, in this case, that'd be density. That's not the same thing as mass or volume. That's basically the combination of the two. So you can't convert grams to liters because, again, they measure two different things. You can't convert meters to grams. They measure two different things. You can't measure meters to liters. Okay, that's not how that works. Now, I should be careful when I say that, though, because you can somewhat convert distance with volume, because volume is just distance in 3 different dimensions. But anyway. So they just, more or less, you need to go from grams to grams, milligrams to centigrams. You need to go from kiloliters to liters. You need to go from hectometers to decimeters. Okay. So then 3, you always need to have the root unit as part of the conversion. So that's this step right here. You always need this one right here, the second table. You need to convert to your basic units. Okay. And then number 4, the 1 goes in front of the unit with the prefix. And again, the reason why that is so that you can just go to this table here. You can say, oh, 1 milliliter or 1 millimeter is equal to 0.001 meters. And you can just plop the 0.001 in front of the meters, because that's your conversion factor. And then look up prefix meaning. So that's like 10 to the nth power, so they all have their meanings here. So they have all these. That'll come in handy somewhat in some applications. I'll just tell you, in a lot of applications that we use, it doesn't. And then you put the root unit label with no prefix. Or I should say that's just an extension off of step number 4 here, or idea number 4 here. So because we need to always, practice this, let's just go through these examples. So we're going to convert 2.3 kilograms to meters. So this is what we're given. So 2.3 kilometers over 1. Make our second table. Kilometers go on the bottom. Meters go on top because we're trying to get rid of kilometers, trying to have just meters. Okay. Because kilometers has the prefix, it gets the 1. I then look over here. I look at my conversion table here. Kilo looks like in 1 kilometer, there are 1 times 10 to the 3 meters, which is a fancy way of saying that there are 1,000 meters in a kilometer. And it looks like that's all we need to convert to, okay, which is awesome for us, super easy. So 2.3 times 1,000, so that should be just 2,300. 2,300 meters. And that would be our answer, because that's still in 2 sig figs, like our original number is. Okay, let's look at the second one here. Second example, we're going to convert 0.0790 megaliters into picometers, which is a bit ridiculous, but still important. Okay. Now here's a great example of where we're going to use our calculators in order to, where we can use our calculators in order to solve for this. I'll also show this, how you can do this on paper. So 0.0790, that's 3 sig figs. And that's, megaliters. And we're going to change those megaliters to picoliters, but we first have to just get it to liters. So megaliters to liters, this gets the 1. How many liters are in 1 megaliter? Again, I'm going to look over here. Here's mega. And it looks like it's 1 times 10 to the 6th power, which is, again, a fancy way of just saying 100,000. But I'm going to put 1 times 10 to the 6th power this time. Okay. And then those would cancel out, and I'm just left with liters. Now I need to get to picoliters. So liters go on the bottom, picoliters go on top. Because picoliters has the prefix, I put a 1 next to it. I look on here, I find pico, and I see that pico is 1 pico liter in this case is equal to 1 times 10 to the negative 12th power. So I'm going to write that, 1 times 10 to the negative 12th power. Cancels out, and it looks like the units I'm left with are picoliters, which is perfect. So then what we would essentially be doing is 0.079, because again it's 3 sig figs, and then that's times 1 times 10 to the 6th power times 1. And on the bottom it's going to be 1 times 1 times 1 times 10 to the negative 12th. So then we can just kind of multiply all that together. So then it would be 0.0790 times 10 to the 6th power, okay, over 1 times 10 to the negative 12th power, okay. Now remember, what do we do? What is it that we do with when we are dividing exponents? It's as if we're subtracting them. So in this case, it would be like, and we already know because 0.0790 divided by 1, well, that's 0.0790. Okay, that's easy enough. But then what's 6 minus a negative 12? Well, 6 minus a negative 12 is going to give us a ridiculous number of 0.0790 times 10 to the 18th power. Oops, I was not showing any of that. My bad. So here, take a minute to see what I was doing there. Sorry about that. So here would be technically our answer. We're not exactly done yet because we should put this in correct scientific notation. So this is initially what we would get. We got to take our decimal here, move it over 2 spaces so that our actual answer is 7.9 times 10, and we moved it 2 spaces to the right. So that'd be 2 minus 18. So our actual final answer here would be 7.90 times 10 to the 16th power. Oh, and also picoliters. Can't forget about those units. Okay. Now, real quick, I'll show you, when you plot that in, if we plot this in right here, if we plot that into our calculator, we will get this answer. Okay. So, get it to a spot where I don't have that nasty glare, if I can find it. Okay, that kind of stinks. Shift there we go. So I'm going to put in here with parentheses, 0.0790 times 10 to the 6th power, 6th power divided by 1 times 10 to the negative 12th power. Then we get here 7.9 times 10 to the 16th power. Now, again, here's another prime example why I don't recommend that you, I recommend that you don't use the scientific notation, use or like the setting on your calculator. If you gave that to me, that would be wrong. Because remember, the number of sig figs is 3, not 2. Okay, so the actual answer is the 7.90 times 10 to the 16th power picoliters. Okay. And then we've got this one down here. Got 2 more. 5.3 kilograms over 1 times, and then we got to put kilograms on bottom. We're going from kilograms to nanograms. So it's going to be another kind of big jump like this guy up here. We're going from a big range to a small range. So, but we got to first go to our basic units, which are just grams. 1, and I know that there are 1,000 grams in 1 kilogram. Those would cancel out and we're left with grams. So now we got to convert grams to nanograms. Got grams there, nanograms there. Nanograms get 1 because it has a prefix. And then how many grams are in 1 nanogram? Look in here, 1 times 10 to the negative 9th. Okay, so then what that's going to translate into, it's going to translate into 5.3 times 1,000 times 1 on top, and then 1 times 1 times 1 times 10 to the negative 9th. Okay, oh, but those cancel out too. Okay. So what that ends up being is 5.3, which is going to be 5,300. That'll be, because if you do that, 5.3 times 1,000, 5,300 divided by just the 1 times 10 to the negative 9th. Now you could do this by hand. Like what you could do here is just, you could have this. You could have 5.3 times 10 to the 3rd power over 1 times 10 to the negative 9th. So 3 minus a negative 9 here is going to give us 12. So it would be 5.3 times 10 to the 12th power nanograms. Yeah, nanograms. Okay. So what I got over here, this is going to be the answer, 100%. And just to prove it to you on my calculator here, 5.3 times 10 to the 3rd power divided by 1 times 10 to the negative 9th power. There we have it. In this case, it does give you the right answer because it's 2 sig figs. We started with 2 sig figs. That's what it gives us. That's fine. Okay. And this is probably a good moment here to where, again, limitations of calculators. You don't plot in, units on your calculator here, so you have to remember, to include your units at the end. And just a note, and I will put this in the directions of all your material, that from when we're doing this material from basically now until the end of Unit 6, when you're converting, you have to give me units. You will miss points and you will lose points if you don't put down the correct units in your answers. So make sure you do that, okay, every single time. And then finally, the last problem here, convert 7.14 pounds into centigrams. So we're just basically going from standard units to metric units. Nothing too scary because we've kind of already done it a little bit over here. Or at least the method is still exactly the same, and we've got our conversion table. So 7.14 pounds is what we're given. So here are our old units. We're going to put those on the bottom to get rid of them, and we're changing them to centigrams. Now let's see real quick. We're measuring mass here. We've got pounds to ounces, don't need that. We've got pounds to grams. Perfect, that's exactly what we need. So in 1 pound, there are 453.59 grams. And then we would cancel out those pounds. We're left with grams. So now we've got to convert grams into centigrams. So grams on bottom, centigrams on top. That gets a 1, and there are 0.01 grams in a centigram. Multiply across the top, multiply across the bottom, and then you divide top from bottom. So 7.14 times 453.59 divided by 0.01. So that's going to be 323,863.26 is what our calculator will spit out at us. We'll see here that we started off with 3 sig figs, and we have to keep sig figs, so it looks like just 3 are going to be necessary. So 1, 2, 3. And it looks like here that we have 324,000 centigrams for our answer. Now, this is a prime example here to where the answer doesn't have to be, but really should be in scientific notation. Another way you could write this is 3.24 times 10 to the 1, 2, 3, 4, 5 centigrams. Perfect example there. Realistically speaking, that's the better answer. Both of them are fine. Just remember, like I said, if you go past 10,000, that's really when you should have your answers in scientific notation. Okay. All right, again, I know this is a little bit longer of a video, but there is the video. If you still have questions, any concerns about this material, make sure you reach out to me. I'll also have a video. Let's see, I just thought of it. What was it? I'll put out a video. I think it was, what was it? It was something to do with this, and I can't remember. It'll come to me later on. But anyway, just always keep a lookout for the videos I post and all these other practice videos I'm putting out. I'm putting them out to help you guys. I really hope that you're watching them, and I really hope that if you watch them, that they're really helping you. So please always look out for those, and always be asking questions. I'm always here for you guys to ask me questions. So anyway, that's the video. So thanks for watching here and going all the way through, guys. If you still have any questions, get a hold of me, and I'll see you guys in the next one.